All right, so in this video, we're going to go through sample question 36 from the Society of Actuaries, ExamP list of sample questions. So the question reads, a group insurance policy covers the medical claims of employees of a small company. The value V of the claim made in 1 year is described by V equals 100,000 times Y, where Y is a random variable with the following density function, and K is a constant. Okay. Calculate the conditional probability that V exceeds 40,000 given that V exceeds 10,000. All right, so we're looking for the following. The probability V exceeds 40,000 multiplied by, conditioned on the probability that V exceeds 10,000, just like that. All right, and this is obviously the probability it exceeds 40,000 and 10,000, and I would hope it'd be obvious that that numerator should just be exceeding 40,000, right? Because if you exceed 40,000, you obviously must exceed 10,000 by default, and what's our denominator? The probability of exceeding 10,000. So we're not given any information on V itself. We're given information on Y. Okay, and this is going to be a problem where we have to first, before doing anything, figure out what the actual density function for Y is. Right? Because we're only given the density function with this constant up here. We need to figure out what that constant is. How do we do that? If we integrate over the entire interval for a density function, we should get out 1. Right? Integrating a density function gets you a probability. Integrating over the entire space should have it equal 1. That's kind of one of the most base kind of rules in probability. So 1 should be equal to the integral from 0 to 1, right? Those are my bounds here, of k times 1 minus y raised to the 4th power, dy. All right, k I'm going to take out because it's constant. And this is just calculus. I'm going to kind of assume this is pretty simple. It's not a terribly difficult equation. It's U substitution, where U is equal to 1 minus y, and du is equal to negative dy. Okay. Right? Yes. So this ends up being 1 equals 0 to k, 0 to 1 of negative u to the 4th du. And integrating this, I end up with 1 equals k, and then in parentheses, negative 1 over 5 multiplied by u, which u is equal to 1 minus y, raised to the 5th power, evaluated from 0 to 1. Okay, putting this in, we end up with 1 equals k of 0 minus, and I'm assuming I'm going to skip a few steps, right, just for kind of speed, just so this video is not longer than it needs to be, minus negative 1 over 5, which is simply just 1 equals 1 over 5k. All right, because all I did was I evaluated this integral from 0 to 1, okay? And then I figure out k is equal to 5. So the actual density function I'm given here is the following. let's see, what is it? 5, 1 minus y to the fourth from 0 to 1. Okay, and that's what we're going to use for the remainder of this problem. So, we're going to need two separate things. We're going to need the probability that v is greater than 40,000 and the probability v is greater than 10,000. Okay, and I'll grab a separate sheet of paper. So, the probability that v is greater than 40,000. Well, in our problem, we know that v is equal to 100,000 y. So this is going to be kind of like a transformation. The probability that 100,000 y is less than 40,000 is essentially going to be the same thing as the probability of v. Sorry, not being less than, being greater than 40,000. Sorry if I've been saying less than. The notation's correct though. Okay. So we divide by 100,000 to both sides, right? And we get 0.4, right? So we're looking for the probability that y is greater than 0.4, and that's our numerator. Similarly, we're looking for the probability that v is greater than 10,000, which is the same thing as the probability of 100,000 y greater than 40,000, which is the probability of, sorry, 10,000, there we go, which is the probability of y being greater than 0.1. And we need to figure out each of these. Well, we can integrate our new PDF, right? So for the this one, greater than 0.4, we integrate from 0.4 to 1 of 5 times 1 minus y to the fourth. I can take out the 5 and integrate from 0.4 to 1 of 1 minus y to the fourth. This should be dy. Right, and from here, we actually already kind of know what this will integrate into. Okay, so this is going to end up being 5 multiplied by negative 1 over 5, because we computed this earlier, 1 minus y raised to the fifth, except we're just evaluating differently. Rather than evaluating from 0 to 1, we're evaluating from 0.4 to 1. Okay, evaluating from 0.4 to 1 gets us, so let's see, here it's 1 minus 0.4, which is 0.6. 0.6 raised to the fifth is 0.0776. Sorry, 0.07776. And then multiplied to negative 1/5. Right, evaluating this at 1 gets us 0. So this is going to be 5 multiplied by 0 minus negative 0.015552. And evaluating that whole thing gets us the following, 0.07776. Okay, and that's our numerator right here. So 0.07776 divided by whatever the solution to this one is, right? And I'm basically doing the same steps, so I'm just going to kind of speed run through this. So 0.1 to 1 of, and then I get the 5's on the outside of 1 minus y to the fourth dy. We're evaluating 5 out here. And this is going to be negative 1 over 5, 1 minus y to the fifth from 0.1 to 1. And this is going to end up being 5 times 0 minus, and that's going to be 0.9 to the 5th times negative 1 over 5, which is negative 0.118098. And then finally evaluating this, gets us 0.59049, which is our denominator. Finally, computing this, 0.07776 over 0.59049 gets us 0.131687, which is approximately around 2 decimal places, 0.13, which would be our final answer. Okay? Main takeaways from this problem. When you're given a PDF, right, and it's either got some coefficient up front that you don't know the value of, right, some constant, or it's talked about, it talks about in terms of like, oh, the density is proportional to this expression. What you're going to want to do in order to find this is integrate over the entire interval and set it equal to 1 in order to find out what that value is. Next, if you're asked to find the CDF or the PDF of something, but given it in terms of something else, that's a transformation, right? That's something you should be very familiar with by the time of your exam. Okay, so in this case, we had the probability of V being greater than 40,000. That's what we were looking for. However, we were given it in terms of something else. We were told V in terms of Y. So I made that substitution. And I isolated Y on this side. And I ended up finding out that the probability that V was greater than 40,000 is the exact same thing as the probability that Y is greater than 0.4. And since that's what I had a density for, that's what I could find the probability of. All right. Hopefully that makes this question a bit more clear if it was confusing you. If you want to check out more worked out problems, I got a playlist. If this video helped you out, hit the like button because that definitely helps me out. Okay. But other than that, good luck, guys.